Hi viewers, welcome to today's episode of Euler Mathematics class. In today's video, we'll be finding the derivative of sine inverse of x. I know most people will make this mistake. Saying this, you'll be like, maybe it's something as a 1 over sine x. Because since they say 1 over x is something as x raised to the power minus 1, you'll be like, okay, let me make this to be called sine this. No, you are wrong. Sine inverse of x is a different thing. So right now, how do we differentiate this? Had it been it's truly like this, you can just use your quotient rule and simplify this down. But it's not the same thing. So how do we do that? Watch the video from the beginning to the end and you understand what I mean. So let's go straight to the point. This is a solution. So let's define the function. Let y is equals the function itself, sine inverse of x. But before doing the next step, let me remind you of something. When you have a function, let's say not really a function, when I have a variable x raised to power minus 1 multiplying by x raised to power 1, this is same thing as x raised to power. This is multiplication, same base, so I'll add the power. Remember from the law of indices. So since it's multiplication, minus 1 plus 1, which is equals x raised to power 0. So since it's x raised to power 0, anything raised to power 0 is what? 1. So this is equals 1. The reason I brought this is I want to explain something here. Since we've defined our function sine inverse of x to be y, the next thing is to take the sine inverse of, the sine of both sides, such that when I say sine y is equals sine inverse of x. Now take a look at this. I can decide to put this in a bracket and it's still something. Do you get? So right now, I'm having sine y is equals, sine and sine will cancel out. It's supposed to be 1, but 1 times x, this is going to be x. So at least you understand what I mean now. Taking the sine of both sides, arriving at here. The next step is to, let's name this equation 1. I'm just deciding to name this. I want to refer it in a certain level. So right now, let's differentiate this implicitly because this is a function, this is a trig function, but it's having y inside. So we differentiate this implicitly. Differentiating implicitly, sine, derivative of sine is cos. So you write your cos y, but you have to multiply by the derivative of y, which is what? The y, the x. Derivative of x is what? 1. In case you are not familiar with implicit differentiation, I have a video already on implicit differentiation, but I'll still make more so you understand it very well. So cos y dy dx is equals 1. So after this step, remember we are just trying to find derivative of this. So that means we need just this portion, right? So what we'll do is let's divide both sides by cos y. Dividing both sides by cos y, we are going to have dy over dx is equals 1 over cos y. We're almost there, but I have to remind you of something again. We have one more thing to talk about. From our trigonometric identities, I've not made videos on that, but trust me, our next videos will be about trigonometric identities. So in case I do something that is somehow confusing now, you, should I say, be patient enough, so I will make videos for you to understand this. So cos y, there's an identity that says cos square y plus sine square y is equals 1. So this is just an identity. We call it the square identity. So if really this is that, then that means we have cos y here. That means let's make y subject of the formula from there. Sorry, not y, but cos y. So let's see, this is cos square y is equals 1 minus sine square y. But when this cross, that's why I'm having minus. It means this, I have minus. So we have to take the square root of both sides so that this square can go. We are going to have cos y is equals square root of 1 minus sine square y. So this is actually our cos y, right? So our dy over dx is equals 1 over, instead of cos y, remember what I said? You put square root of 1 minus sine square y. We're almost there. Should I say we've arrived, but one more thing is left. Remember what we said about sine y. From our first definition, we said sine y is equals x. That means in place of sine y, we can put x. But this time around, it's sine square y. So we'll replace it by x squared, right? So all in all, the derivative of sine inverse of x is going to be dy over dx, which is equals 1 over square root of 1 minus, I said instead of sine square y, we are putting, if you just square both sides, you just arrive here, we are putting what? X squared. And this is the derivative of sine inverse of x. Thanks for watching. And please don't forget to